So guys, in today's video we are going to see the chapter called as your alcohols, phenols and ethers. Alva. So basically I think this will be one of the interesting topic for the boys since they can see the word as alcohols. Alva. Sorry, just for kidding. So basically in this chapter we are mainly going to deal with these three respective compounds, in which we will be dealing with the hydroxy group as a functional group, and as that of your ethers, which will be seeing what will be its general formula. Okay, so basically in the previous case, whatever we saw as an haloalkenes and an haloarenes, you do remember that whatever the X group we were adding for our alkyl or an aryl system was just a substituent. I repeat, in a haloalkenes and the haloarenes, whatever the halogens we were going to add to your alkenes or your arenes, they were just the substituents. But when it comes to this chapter, the alcohols, phenols or the ethers, you have to make sure that today onwards, whatever the chapter we are going to see in the organic chemistry will be with respect to the functional groups. I repeat, it will be with related to that of your functional groups. Is that clear? So first and the foremost duty of us, it would be that we have to understand what is the major difference between alcohols, phenols and ethers. So basically guys, whenever we are talking about the alcohols, you do remember that. So it's an aliphatic system to which your one or more hydroxy group is attached. So what you call as an alcohols then. So they are the organic compounds in which we could see that one or more hydroxy groups will be attached to an aliphatic system. For example, if I am going to write it as CH3OH, or in case I can write it as CH3CH2OH, what we are observing over in this examples, whatever the hydroxy group is there, it has been bonded to an aliphatic system. Alva, it is an aliphatic system. I'm just giving a brief introduction. Then after later, further in this chapter, we are going to go with the depth analysis of what do you mean by alcohols, phenols and ethers. Just before diving into the depth of this topic, first let us understand certain brief important things. So this is called as what? Your alcohols. Coming with respect to the phenols, of course you can only say it. Yes. How can I say phenols? So basically here what happens, the OH group is attached to the carbon atom of the benzene ring directly. For example, the common thing of phenol we can write as what? Yes, this will be our phenol. So what has happened over here? Whatever the hydroxy group is there, it has been directly attached to that of your benzene ring. Alva. So such compounds are called as what? Phenols. Similarly, for example, if I am writing an alcohol, I will be writing it as ROH. Yes or no? But in case, if I am going to do in such a way that if I am, removing this hydrogen, and instead of that hydrogen, if I am replacing another alkyl or an aryl group, so whatever the compound I am going to get, this itself is called as our ethers. Very much important. I repeat, so in the alcohols, when we are substituting our hydrogen with respect to an alkyl or an aryl group, so they will be called as what? Yes, they will be called as your ethers. Similarly, we can also state that here you have taken example of an alcohol. Similarly, in case if I am having an hydrocarbon, so to this hydrocarbon, if I am doing an addition of an alko-oxy group, and there the alko-oxy group, that means what? Alkyl group will be there, which is representing your alkyl. Oxy means oxygen. For example, if I am having CH4, yes, what I am going to do? So I am going to substitute one hydrogen of this hydrocarbon with an alkoxy group. For example, CH3OCH3. Yes, what I have done? So this is my hydrocarbon, alpha, which was what? Methane. From that methane, what did I do? I have substituted one hydrogen with an alkoxy group. Here, which is the alkoxy group? Methoxy group. Alpha. Alko means your methane. Meth I am taking, which is attached to an oxygen, which is called as methoxy. Okay, so this is called as what? Alkoxy group. So there are two tendencies. How can get our ethers? One is what? From the alcohol, just you have to substitute your hydrogen with an alkyl group. Other case is what? From the hydrocarbons, you have to substitute hydrogen with an alkoxy group. But major funda what we have to remember, in an alcohols, the OH group is attached to what? Aliphatic system. In a phenols, the OH group is attached to the benzene ring. Whereas in an ethers, what we can say, our alkyl group is attached to an alkoxy group with the general formula of what? ROR dash or ROR, where your R and R can be same or they can be also different. So of course, till now in the previous classes or in your lower classes, we were knowing about alcohols and phenols. I think this will be a new concept for you to remember what do you mean by an ethers. So this is the representation of your ethers. You have to remember it. How will you write it? ROR. This is a general formula for your, or we can say a general representation for your ethers. Is that clear? So as we have seen in the haloalkenes and the haloarenes, here also we are going to do the classification. So first and the foremost thing we will be doing with the classification of alcohols. Classification of alcohols. So basically, first important classification we are going to see, it's depending upon the number of our hydroxy group. Number of our hydroxy groups which is attached to our system. Hydroxy group. So depending upon the number of the hydroxy group, we are mainly going to classify our alcohols first of all as a monohydric alcohol. Monohydric alcohol. I think you can only give the definition. Yes. So these are the compounds which is containing only one hydroxy group. What you can say? Monohydroxy alcohol means these are the compounds which is containing only one hydroxy group. Is that clear? For example, as I mentioned over here, you can take it as what? CH3OH, or also we can take as what? Our phenol. So these all are the cases where we can see as what? In all these compounds, you are having just one hydroxy group. So it is called as what? Monohydric alcohol. Similarly, if I go further, I will be calling it as a dihydric alcohol. Dihydric alcohol. So of course you can only define it. So these are the compounds which contains two hydroxy groups attached. Two hydroxy groups are attached. For example, CH2OH, CH2OH. Yes, you can just see that two hydroxy groups are present. Similarly, you can also write for an arene system. Yes, in this way, OH and an OH. You can write it in this way. So in a compound, we can just see that two hydroxy groups are attached. So it is called as what? Dihydric alcohol. Similarly, you can also call it as a trihydric alcohol. Yes, trihydric alcohol. So of course you can just define it with me. Yes, in which you will be having what? Three hydroxy group attached to our compound. So for example, CH2OH, CH2OH, CH2OH. Similarly, if I am going to write for arene system, OH, OH and an OH. So what we are observing, so in these compounds, yes, there are three hydroxy group is attached. Is that clear? Similarly, we can go for a polyhydric alcohol. How can we write for polyhydric alcohol? Yes, polyhydric alcohol. So polyhydric alcohol means what you can say? Alva, till 3 we have seen. So after 3, how can you define it? So these are the compounds in which there will be more than 3. What you can say? There will be more than 3. More than 3. Yes. More than 3 hydroxy groups. More than 3 hydroxy groups attached to our compound. For example, we can take it as a sorbitol. So sorbitol means how can we write? Basically, it is like the CH2CH, CH, 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 1, 2, 3, 4, 5, 6, CH2. So in all the cases, what we are able to see, OH group is attached. OH and an OH. So you can just see that here we are having the hydroxy groups more than 3. So this is the compound we can say as a poly. It is coming under the classification of polyhydric alcohol. Common name is called as a sorbitol. Basically, you just remember this because we will be seeing how to name it in our nomenclature. Common name, it is called as what? Sorbitol. So of course, what is the classification of just we have seen is a depending upon the number of our hydroxy group, and there we have classified our alcohols as monohydric alcohol, in which we are having just one hydroxy group attached to our compound, dihydric alcohol, in which we are having two hydroxy group attached to our compound, trihydric alcohol, in which 3 hydroxy groups are attached to our compound, polyhydric alcohol, in which more than 3 hydroxy groups are attached to the compound. It will be called as polyhydric alcohol. Yes. Then the major classification, as we have seen in our haloalkenes and haloarenes, we are going to see here also. That is the next classification we are going to see, which is called as compounds containing CsP3OH bond. That means what? Whatever our hydroxy group is attached, it will be attached to the carbon atom which will be sp3 hybridized. The same phenomena as we have seen our haloalkenes and the haloarenes. But the major difference is what? In the haloalkenes and haloarenes, we were seeing for it halogens to have been attached to the carbon atom. But here we have to observe as what? Our hydroxy group will be attached to our sp3 hybridized carbon atom. So majorly we will be classifying this one first of all as a primary alcohol. Primary alcohol. That means what? Yes. So in this type of alcohols, what will be happening? The OH group. See, whenever I am writing my functional group, a hyphen and an OH only I have to write. This is a mere representation to write your functional groups or any substituents. Okay, hyphen OH. So how can you write? So the hydroxy group will be attached to primary carbon atom. Will be attached to primary carbon atom. Of course, in our previous classes we have seen what do you mean by primary carbon atom. I think you know it, no need of repeating it. So what is the examples? Yes, we can give an example of CH3CH2OH, or we can also say as CH3OH. This can both are what? You can just see that whatever the hydroxy groups are there, they are attached to which carbon atom? Of course, it is primary carbon atom, and moreover it is a sp3 hybridized. A single bond is existing. So whenever our hydroxy groups are attached to the primary carbon atom, so they are called as what? Primary alcohol. What do you mean by primary carbon atom? The carbon atom which is further attached to only one carbon atom. Similarly, the second part is called as what? Secondary alcohol. Secondary alcohol. So of course what you could say, here the hydroxy group will be attached to the, yes, will be attached to secondary carbon atom. Attached to secondary carbon atom. Can you give me an example? How will you write for a secondary carbon atom? First you have to judge in that way. How can I write a secondary carbon atom? Of course, a carbon which will be attached to the two other carbon atoms. Then you just try to balance its valency. We know that around carbon we want how many bonds? 4 bonds. Of course, for this carbon 1 bond is there. I require more 3 bonds. So I can write it as here CH3. Similarly, over here 1 bond is there, 3 hydrogens. So it has been completed. And one important thing is what I'm writing for a secondary alcohol. So OH will be attached now this carbon atom. Okay, 1 bond I have written OH. So for this carbon atom, how many bonds have been over? 1, 2, 3. So it is requiring 1 more bond. I can write it for H. This is the way you have to, when you are in lower classes, you are trying to write for the first time. This was my way to remember certain things. You have to go with the concept wise. Don't ever by heart. So we know what? Secondary alcohol means what? OH should be attached to the secondary carbon atom. So of course here what has happened? The hydroxy group is attached to the secondary carbon atom. What do you mean by secondary carbon atom? The carbon atom which is bonded to the 2 other carbon atoms. Is that clear? Similarly, Another thing we are going to see, which is called as what? Tertiary alcohol. It's called as what? Tertiary alcohol. So what do you mean by tertiary alcohol? Yes, the hydroxy group will be attached to what? Yes, this tertiary carbon atom. Tertiary carbon atom. Is that clear? So let us do it. How to write its formula? Of course, tertiary carbon means the carbon which will be bonded to the 3 other carbon atoms. One thing. So of course, now if I am writing over here C, C and C. So for this C, 1 bond is there. It requires more 3 bonds. So I can write it for H. Yes. Similarly over here CH3, CH3. 1, 2, 3 bonds are already present for this carbon. And I know that for a tertiary alcohol, the OH bond should be attached to this carbon atom. So I will be writing a 1 more bond. So of course now 1, 2, 3, 4. 4 bonds are present. So this will be your formula for tertiary alcohol. An example I can say. An example for our tertiary alcohol. So this was one type of classification where we are seeing where our OH bond is attached to our sp3 hybridized carbon atom, which has been classified as primary alcohol, secondary alcohol, tertiary alcohol. As in the case of your as in the case of your haloalkenes and haloarenes, we saw the next classification was called as what? Allylic halides. Alva. Here what we can call it as, yes, the next classification among in this concept itself will be called as what? Allylic, yes, alcohol. Allylic alcohols. So what will be happening in allylic alcohols? Yes, whatever the hydroxy group is there, the hydroxy group will be attached to what? Will be attached to sp3 hybridized carbon atom. Hybridized carbon atom. But what will be happening? Yes, that sp3 hybridized carbon atom will be adjacent to the double bonded carbon atom. Alva will be adjacent to the carbon-carbon double bond. Carbon-carbon double bond. Same as we have seen in the allylic halides. There we use the word as what? Our halides will be attached. But here we are dealing with what? Alcohols. So here what will be attaching? Our hydroxy group. So allylic alcohols means what? The hydroxy group will be attached to the sp3 hybridized carbon atom. Why it will be called as an allylic? Because that sp3 hybridized carbon atom will be adjacent to the carbon-carbon double bond. Simple example, if I choose, it will be written as CH2 double bond CH, single bond CH2OH. Alva. So you can just see in this example, the hydroxy group is attached to what? sp3 hybridized carbon atom. Why it is called as sp3 hybridized? Because you can see it is having a single bond. Alva, it is having a single bond. But this sp3 hybridized is adjacent to what? CC double bond. Okay. What is the hybridization of this carbon? It is sp2. Do remember. Okay. But here we are talking about what? Our compounds containing sp3OH bond. So this is the reason this can be taken as an example for allylic alcohols. Is that clear? And do remember guys, I think in my notes I have given in this way. CH2 double bond CH, single bond C, 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 like this, and this way. So as I mentioned many times, if I have not written anything, means what does it mean? That will be having a CH3 and the CH3 group will be attached. That is, methyl group is present. Many cases will not be given. Sometimes they will just leave it. You should just assume. It should be a, you can say, a universal assumption that whenever nothing has been written against the bond, means you should remember that it will be a methyl group. Okay, don't ever think it will be just an hydrogen. ಯಾವುದೇ ಒಂದು ಬೇರೆ group ಇದ್ರೆ we have to mention. In case we are not mentioning, means it is represented by what? Methyl group. Okay, yeah. So this is also an example for what? Allylic alcohols. Why? Because our hydroxy group is attached to which carbon? sp3 hybridized carbon atom, which is adjacent and then next to. Next to what? CC double bond. Is that clear? Can you please say now the next alcohol? Which will be our next alcohol then? Yes, it is called as what? Benzylic alcohol. Benzylic alcohols. So of course, benzylic halides ಅಲ್ಲಿ ಏನು ಹೇಳಿದ್ವಿ? The halides will be attached to the sp3 hybridized carbon atom, which will be adjacent to the benzene ring or an aromatic ring. But here benzylic alcohol. So what we have to replace? Just the word of halide. So that is our hydroxy group will be attached to yes, sp3 hybridized carbon atom, sp3 hybridized carbon atom, which is next to the aromatic ring, Alva. For example, as we have seen, yes, this is our benzene ring. But what has happened? These carbons are what? sp2. So we need one more carbon, Alva, which is what? sp3. So idike OH group is attached. So this can be an example for which one? Our benzylic alcohol. So what has happened? Our hydroxy group is attached to the sp3 hybridized carbon atom, which is next to this benzene ring. Is that clear? So we have seen the classification over here. What we have seen? The compounds in which our hydroxy group is attached to the sp3 hybridized carbon atom. And first of all, we have seen in that classification the primary alcohol, secondary alcohol and tertiary alcohol. How can we define it? In which our hydroxy group will be attached to the primary carbon atom, secondary carbon atom and tertiary carbon atom respectively. So by that classification, we can classify the first part. Second part, what did we see? About allylic and benzylic alcohols. In allylic alcohols, what is happening? The hydroxy group is attached to the sp3 hybridized carbon atom, which is next to or which is adjacent to the carbon-carbon double bond. Similarly, when you're talking about your benzylic alcohols, what did we see? Yes, our hydroxy group is attached to the sp3 hybridized carbon atom, which is next to our aromatic ring. Alva, aromatic. Why I'm talking as an aromatic? Because it is having a definition which follows your Huckel's rule. It should not be only the benzene ring. Any other rings also it can, but it has to follow Huckel's rule. 4n Huckel's 4n plus 2 rule na follow agbeku. An aromatic system anta ಹೇಳ್ತೀವಿ. If you're not remembering, just recall from your first PUC chapters how can a system is called as an aromatic system. So that is the reason. Instead of saying as a benzene ring, I'm much particular. I'm saying it as an aromatic ring. Is that clear? Now let us see the another classification in which what would be happening. The compounds in which our OH group will be compounds in which our OH group will be attached to sp2 hybridized carbon atom. sp2 hybridized carbon atom. Alba. Same as the case of your haloalkanes part. But what happened over there? There we use the two terms. One was called the vinylic halides or vinyl halides and the aryl halides. But here what we are going to study, instead of aryl halides, we are going to see phenols. Okay, instead of aryl halides, we are going to see a new name called as your phenols. We are not saying as an aryl alcohol anta heltilla, adu badhe enanta heltidivi, phenols anta heltivi. As usual for vinylic halides, how did we use? Instead of that one, here we are going to see vinylic alcohol. Vinylic alcohol. So this is the major two classification under this classification in which your hydroxy group will be attached to sp2 hybridized carbon atom. So how can you define it? Yes. So in a vinylic alcohol, what happens? The hydroxy group is attached to our sp2 hybridized carbon atom directly. Alva, sp2 hybridized carbon atom ಗೆ direct ಆಗಿ bond ಆಗಿರುತ್ತೆ. ಅದನ್ನ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ? Vinylic alcohol. For example, CH2 double bond CH single bond OH. So what we are observing over here? Whatever the hydroxy group is there, it is directly attached to what? CC double bond alva. ಈ ಒಂದು ಕಾರ್ಬನ್ sp2 hybridized carbon atom ಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬಾಂಡ್ ಆಗಿದ್ರೆ ಆ ತರ ಒಂದು ಕಾಂಪೌಂಡ್ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಆ ತರ ಒಂದು ಆಲ್ಕೋಹಾಲ್ ಸಿಸ್ಟಮ್ ನ ವಿನಿಲಿಕ್ ಆಲ್ಕೋಹಾಲ್. Coming with respect to the phenols, what you can say? Yes, the hydroxy group, what will be happening? It will be directly attached to our aryl carbon. Alva, aryl carbon ಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಅಟ್ಯಾಚ್ ಆಗಿರುತ್ತೆ. You can just see, ಇಲ್ಲೂ ಕೂಡ ಏನಾಗಿರುತ್ತೆ? EC is what? CC double bond. Alva, so it is what? sp2 hybridized itself. So whenever our hydroxy group is directly attached to the aryl system or the aryl carbon, so ಅವಾಗ ಏನಂತ ಹೇಳ್ಬೋದು ನಾವು? It is also a phenols. That classification is called as phenols. So of course this is its IUPAC name is also phenol and common name is also phenol. Similarly this one OH CH3. So ಇಲ್ಲಿ ಕೂಡ ಏನಾಗಿದೆ, OH group is directly attached to our aryl system or the aryl carbon alwa. So this is generally, it is having a name, but it will generally call as what? Derivatives of phenol. Derivatives of phenol alwa. Since if this is not there, what it will be called as? Phenol itself. Since it is having one substituent, what it will be called as? Derivatives. We are deriving something by using your phenols itself. So it is called as what? Derivatives of phenols. So in what we have learned today, basically we have seen what do you mean by alcohols, phenols and ethers. Then we came to know their classification of alcohols. We came to know as what? Depending upon number of the hydroxy group present in a system, we are classifying it as a monohydric alcohol, which contains only one hydroxy group attached to the compound. Dihydric alcohol, in which two hydroxy groups are attached to the compound. Trihydric alcohol, in which three hydroxy groups are attached to our compound. And also we saw your polyhydric alcohol, which means what? Having more than three hydroxy groups which is attached to the compound. Then we saw what? Compounds containing your sp3COH bond. That is, your hydroxy group will be attached to the sp3 hybridized carbon atom. So there we have seen the classification, which is called as your primary carbon atom, in which our hydroxy group is attached to the primary alcohol, in which our hydroxy group is attached to the primary carbon atom. Then your secondary alcohol, in which our hydroxy group is attached to the secondary carbon atom. Similarly, tertiary alcohol, in which our hydroxy group is attached to the tertiary carbon atom. Then we saw the same under this same classification, which is called as our allylic alcohols. So what do you mean by allylic alcohols? The hydroxy group is attached to the sp3 hybridized carbon atom, but that sp3 hybridized carbon atom is adjacent to the CC double bond. Alva. Then we saw benzylic alcohols, in which the hydroxy group is attached to the sp3 hybridized carbon atom, which is adjacent to the aromatic ring. Alva. Then we saw another classification, in which our hydroxy group is attached to what? sp2 hybridized carbon atom, and there we have seen vinylic alcohols and phenols as the two major classification. Vinylic alcohols, what we have seen, the hydroxy group is attached directly to the carbon-carbon double bond, or we can say sp2 hybridized carbon atom. Whereas in the phenols, what we are seeing, the hydroxy group is attached to our aryl carbon. This is our aryl. So allenaga ಆ ಒಂದು ಕಾರ್ಬನ್ಗೆ ನಿಮ್ಮ OH group is directly attached ಆಗಿದ್ರೆ ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ? Phenols. Is that clear? Next we are going to see how to name the given compounds of alcohols under the concept called as nomenclature of alcohols. Is that clear? So now let us see how to name our alcoholic compounds. Nomenclature. So basically it will be quite somewhat different when compared to that of the naming of our haloalkanes and haloarenes. Why is it so? Because whatever in haloalkanes and haloarenes we were seeing, the halides, the halogen part, they were acting as a substituent. Alva. So whenever a substituent comes, what happens? Yes, its name will be coming as a prefix. But here what we have said, I have said earlier, here now whatever we are seeing is called a functional group. Alva, the hydroxy group irbodu, further coming carboxylic group irbodu, avella ಈಗ ಜನರಲ್ ಇದನ್ನ ನೋಡಿದಾಗ ಏನು ಮೇಜರ್ ಆಗಿ hydroxy group will be acting as what? Functional group. So it will be acting as what? Suffix. Alva. So when you are writing its name, it will be coming at the last. Alva. I have given you the rule how to write. First comes the prefix, then the root word, then comes your suffix. The same way. Similarly, when you're talking about now nomenclature, generally you have to remember what? So whenever we are writing the name of an alcohol for an alkane, generally what will be happening? So this E will be replaced by all. So we'll be getting the name as what? General name as alkanols. Alva, alkanol, where you can just see that E is replaced with OL, all. But if you are having more than one hydroxy group, for example, you're having a dihydric alcohol or a trihydric alcohol, then what we have to do? In such cases, we have to use a multiplicative prefix. That means what? For example, if you're having two hydroxy groups are present, means I have to use the prefix as di. If three are present, tri, along with their positions. For example, if I'm just saying, give the example as what? CH3OH. Of course, this is not having any substituent, so we are not having any prefix. So what will be the root word, how many number of carbon atoms? One carbon atom. Yes, meth. Alva, meth anta baribodu. Next to it is having a single bonds. It is having what? Single bonds. So ಏನಾಗಿರುತ್ತೆ? Yes, it comes under the homologous of AN. AN ಆಗುತ್ತೆ. Next ಏನ್ ಬರುತ್ತೆ? The functional group ಯಾವುದು ಇಲ್ಲಿ? Alcohol. So we know whenever we are having an alcohol functional group, we'll be using the secondary suffix as what? OL, all. So name will be called as what? Meth and all. Alva. Similarly, if I am going to write what? CH3, CH, CH2, CH3. And here I am having the OH. Now the question arises, from where I have to number? Alva, yakane position baribeku. Remember, whenever you are having the functional groups, that carbon atom should get the least number. Alva, ನಾವು ಯಾವತ್ತೇ ಆಗಲಿ ನಂಬರಿಂಗ್ ಮಾಡೋದು ಬರೀ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಗೆ, ನಾಟ್ ಅದರ್ ದ್ಯಾನ್ ದಿ carbon atoms will not going to number any other atoms. Only the carbon should be numbered. So now when we are having such things, we'll be generally having a doubt whether we have to number from here or here. So do remember, whenever you're numbering, the carbon atom which is bearing the hydroxy group should get the lowest number. So if I number from here, what happens? 1, 2, 3 I am getting, which will be highest. When I compare to the numbering from here, it will be having 1, 2. So now this rule should be followed. So this will be 1, 2, 3, 4. So how can you write? Yes. First what you have to write? There is no prefix since there is no substituent. So first root word, number of the carbon atoms. 1, 2, 3, 4. 4 carbon atoms means bute. Single bonds are present. That means the homologous series will be AN. Then I have to what? The functional group present is what? Hydroxy group. The functional group name will be what? All. Along with the position. So in position is second position. So butane hyphen 2 hyphen all. Is that clear? So what will be the name? Butane 2 all. So in case if I am having the compound as CH2, CH, CH2, and if I am having here also OH, OH, and an OH. How can I name it? Alva. Of course, you can number from either ways, no problem. So 1, 2, 3 is also same. 1, 2, 3 is also same. But how will you name it? Yes, first I have to write the root word because it is not having any prefix. Substituents ಯಾವುದು ಇಲ್ಲ. Direct ನಮಗಿರೋದೆ functional group. So first ಏನು ಬರಿಬೇಕು ನಾವು? Root word. ಎಷ್ಟು root word? Number of the carbon atoms. 1, 2, 3 means probe. Good. Next what I have to write? The primary suffix, that means its homologous series, whether it is an ane, ene or ine. Yes, single bonds are present unto, so it is what? Ane, prop, ane. Yes. Then what I have to mention? The, yes, secondary suffix, that is my functional groups along with their positions. ಯಾವ ತರ ಬರಿಬಹುದು ನಾನು? Yes, hyphen 1, 2, 3. And we have seen whenever we are having more than one hydroxy groups, you have to use the multiplicative prefix as what? Di, tri, tetra. But here how many we are having? 3 such groups are present. So what we should write? Hyphen, I have to use the multiplicative prefix as tri. Since we have to indicate what is the number of your hydroxy groups are present. Then afterwards all. So propane 1, 2, 3 triol will be the name of IUPAC name of this compound. Is that clear? Now let us check some other common examples. Yes, CH3, CH2, CH2, OH. So how will you number it? From where you will number? Yes, the carbon atom bearing the hydroxy group should get the least number. So ಎಲ್ಲಿಂದ ನೇಮ್ ಮಾಡಬಹುದು? 1, 2, 3. Some mad fellows are there who will number from here. Don't do that one, okay? We have to only number the carbon atoms. Is that clear? So how will you name it now? Yes. What will be the root word? 1, 2, 3 carbon atoms means probe. What will be its homologous series? Is single bonds? Ane. Alva. Then you have to indicate there's no need of indicating, but if you want to indicate one, all also you can write, or you can directly write it as propanol. This is understood. ಏನು ಬರ್ದಿಲ್ಲ ಅಂದ್ರೆ position 1 ಆಗಿರುತ್ತೆ ಅಂತ ಅರ್ಥ. So propane 1 all. Certain times in your competitive exams they can give you the common name also. Do remember this, whatever written is a IUPAC name. Its common name will be N-propyl alcohol. What will be called as N-propyl alcohol. Let us go with one more now. CH3, CHOH, CH3. Yes. So in the number either ways you can number, no problem. Alva carbon atom will bearing the hydroxy group will getting 2 number itself. Alva second position alle irutte. So 1, 2, 3. Yes. So now what will be getting? Yes, propane hyphen 2 all. Alva. So this is what your IUPAC name. So when I am coming with respect to what your common name, it will be called as what? Isopropyl alcohol. Isopropyl alcohol. So these are certain common names you have to remember. Okay, this is called was isopropyl alcohol. Similarly, in case if I am going to write as, yes, in this way, CH3CH CH2OH, and let me take it to you, CH3. You're having like this. Then what you will do? Of course, now I have to number from where? Yeah, even though you are having the substituent, the functional group should bearing carbon should get the least number. Of course, in the nomenclature rules we have seen. So this will be 1, this will be 2, this will be 3. Yes or no? So what will be number naming it? Yes. Now this is having a substituent. Till now, whatever the examples we were seeing, it was not having a substituent. So now it is having a substituent. So yes, we have to make use of our prefix. So in prefix second position methyl. So write first 2. Yes. Hyphen. The first letter should be capital. This is followed in all the cases. 2 methyl. Okay, I have written my prefix, secondary prefix na bardidini. Alva 2 methyl. Next, what I have to do? My root word. Root word is 2, 1, 2, 3. Parent chain ಎಷ್ಟು carbon atom untu anta nodkobe. This is my parent chain alva. So it is having 3 carbon atoms. So 3 means prop. 2 methyl prop. Then what will be a primary suffix? That is your homologous series. It will be ane because it is having single bonds. So propane. Next, what we have to do? At what position it is having OH? Yes, in the first position. So propane hyphen 1 all. Why I have not written E? So whenever you are having a vowel, we have to take out that E. Of course, you are knowing it. And of course, when I was teaching this nomenclature, I have said we have to replace E with all. This is a common rule. Whenever we are writing a vowel, that previous E will be eliminated. Only for the vowels, do remember. So 2 methyl propane 1 all. Generally, this is having the name as common name as isobutyl alcohol. Isobutyl alcohol. Yes. So this is called common name is what? Isobutyl alcohol. Next, most important thing. If I write it in this way, CH3, 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 OH. So now what you will do? Yeah. Now this has to be written in some way in which we can understand it. So how can I manipulate this structure? See, it's CH3 I have written. Okay. Let me take this C over here. Let me take my hydroxy over here and another methyl group over here. And of course here will be another methyl. Why I have done it? Because we know that we have to select a chain in such a way that we should get the maximum number of the carbon atoms. So now I have selected a chain. In case what will be happening? Only 2 carbon atoms I could have checked. Alva longest chain, it should be much as more straight ಆಗಿದ್ದಷ್ಟು ನಮಗೆ ಇನ್ನೂ ಒಳ್ಳೆಯದು. So this will be how much carbon atoms? 3 carbon atoms. Alva. So of course now 1, 2, 3. So what it will be called as now? Yes, it is having now substituent prefix unto. So 2 hyphen capital M methyl propane 2 all. Alva. So what is the common name? This is called as what? Tertiary butyl alcohol. Tertiary, T-E-R-T and the tertiary butyl. Tertiary butyl alcohol is the common name. Tertiary butyl alcohol common name is IUPAC name ಏನು ಅಂತನೂ ಕೇಳೋ chances ಇರುತ್ತೆ. So what will be name? 2 methyl propane 2 all. This we have seen and I also sent you that what was the mistake you were making when you're writing for the same thing when you're having the halogen. Of course, alva. So whenever like the structures are there, try to manipulate in such a way. Remember, whenever you're manipulating, you should not change its name. Change its name means structure change ಆಗಬಾರ್ದು ಯಾವ ರೀತಿಲೂ. ಎಷ್ಟು ಆ ಕಾರ್ಬನ್ ಆಟಮ್ ಸುತ್ತಮುತ್ತ ಹೆಂಗಿರುತ್ತೋ ಹಾಗೇನೇ ಇರಬೇಕು. ಬಾಂಡ್ ಆ ಕಡೆ ಈ ಕಡೆ ಮಾಡಿ ನಿಮಗೆ ಲಾಂಗೆಸ್ಟ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಚೇಂಜ್ ಸಿಗಂಗೆ ಬರ್ಕೋಬೇಕು. Is that clear? If I am going to take now CH2OH and CH2OH. So what it will be called? Yes, ಅಲ್ವಾ? ಯಾವ ತರ ಬರ್ಕೋಬಹುದು ಕನ್ಫ್ಯೂಸಿಂಗ್ ಇದ್ರೆ CH2 CH ಅಂತ ಬರ್ಕೊಂಡು ಈ ಕಾರ್ಬನ್ಗೆ ಒಂದು OH, ಈ ಕಾರ್ಬನ್ಗೆ ಒಂದು OH. Alva. Then what you can do, it is not having any substituent, so you can directly go with the root word. Root word means number of the carbon atoms is two carbon atoms. So eth. Yes. Then you're having a carbon-carbon single bond. Then we will be having what? Eth, ane. Yes or no? Then what we are trying to write? Yes. Ethane 1,2. This will be 1,2. So ethane al nodi illi naan en martini e barkuntini. Yes or no? Here what I am doing, I have written as E. Why? I will just show you. So next what you have to write the position 1,2, then a hyphen. I am writing now diol. So here this is not a vowel, instead of that it is a consonant. Alva. So vowel bandre matra E na tegebeku. Next time bantu illi D bantu, which is not a vowel. So that is the reason I have retained my E over here. Is that clear? Similarly over here I have made a mistake. So propane hyphen 1,2,3 triol. Is that clear? So here it is coming as T. Okay. Now let me take one compound of your haloalkane. CH2 double bond CH2Cl. And one more of an alcohol CH3 double bond CH2OH. In this way, let me take let me take over here as a Br. 1, 2, 3 CHBr. Okay. One important thing, what did I say? So when we were talking about this, what did I say? Even though you are having the Cl, the first priority was given to our double bond. So that is the reason from where did we start? 1, 2, 3. Why it was so? Among your double bond and your halogen atom, the first priority should be given to our double bond. So that is the reason. What did he write its name? Yes, 3-chloro, 3 hyphen capital C chloro. Then I wrote it as a propene. Alva, propene. But when it is coming with respect to that of your alcohol which is having a double bond, remember, when you have to choose between alcohol and double bond, alcoholic group, a hydroxy group and a double bond group, your double bond, the priority should be given to our functional group. I repeat once again, when we are talking about the alcohol which is having a double bond, the priority will be given to our carbon atom which is bonded to the hydroxy group. So the numbering will be from the carbon atom which will be having your hydroxy group. 1, 2, 3, 4. Why I am saying this, again I will repeat. So whatever the halogen was over here, it was acting as a substituent. Remember, whenever we are having a double bond along with your nitro group, along with your Cl chloro groups or your halogen groups or along with your alkynes group, the first priority will be for our double bond. But when the same double bond is with the functional group, do remember, I repeat once again, when the double bond is with the functional group, the first priority will be for the functional group. It could be any functional group, but the first priority should be given for what? Functional group. It could be OH, it could be COOH, okay, it could be your ketone C double bond. Whenever a functional group and a double bond is there, the first priority should be given for the functional group, the carbon atom which is attached to the functional group. But whenever you are having a substituent and a double bond, the priority first should be given to our double bond. So that is the reason. What did we do here? Here the first priority was given to the carbon which is bonded, which is with double bonded. But here what we have done for the alcohols, we are given the priority for the carbon which is attached to the functional group. In case here we were having a COOH of course that carboxylic group is having C. So that carbon atom will be getting the priority first number. Is that clear? That will be seen in your carboxylic acid chapter. Are you able to understand the difference? So I'll just write it so that it will be clearly left over in your mind. So when double bond is along with the substituents, if I say the substituents as an NO2, your alkynes, first priority is given to double bond. Priority is given to double bond. Similarly, when double bond is along with functional group, when double bond is along with functional group, I'm saying here functional group, okay, because it will be applicable for all the functional groups. It could be ketone, it could be carboxylic acids, it could be your esters, it could be your alcohols. So in that case, what happens? Priority is given to our functional group. Priority is given to the functional group. Functional group. That means what? Whenever you're having a double bond and the functional group, the carbon atom bearing the hydroxy group should get the least number. I repeat, the carbon atom bearing the functional group should get the least number. In this case, it was at the last, so I have written as 1. But in case if it was over here in BR position, so that carbon atom should get the least number. So that is the case. But when we are talking about your haloalkenes or the haloarenes, what we were talking there the priority was given to the carbon atom which has been doubly bonded. That should get the least number. Are you able to judge the difference? Why is it so? Because the halogen here was acting as a substituent. So therefore, that is the reason your double bond was given the priority. But when you're talking about our alcohols, our hydroxy group is acting as a functional group. So that should be given the first priority. Is that clear? So how will you name this now? Yes, it is having now 2 substituents are present. So we can write its prefix. Along with it, how can we write now? You're having a methyl, you're having the bromide. Alpha, one is at the second position and is the third position. So we have to choose with respect to the alphabetical order. Bromide, which comes B. Methyl, which comes as M. So which is first alphabet? B is the first alphabet. So 2 hyphen capital B bromo. Alpha. Next hyphen, you have to indicate the position now. 3 hyphen small letter methyl. Is that clear? So we have completed now prefix. Now what is the root word? 1, 2, 3, 4. So there are 4 carbon atoms. Bute. Next, very important, the homologous series. Till now we have seen it was all belonging to the alkene homologous series, but here what has happened is belonging to the alkene series. So now we have to indicate that position also. In the number margin, so this way we are going. So it will be in the second position. When you are going with respect to from which position you are going, the side you have to take that carbon atom first. So bute 2 hyphen ene. So root word is over, primary suffix is over. Then what you have to add? Yes, now you have to replace this E by hyphen 1 all. So what will be the name? 2 bromo hyphen 3 hyphen methyl bute hyphen 2 hyphen ene 1 all. Is that clear? So what is the main difference you have said between your haloalkenes and haloarenes and your alcohols? In haloalkenes and haloarenes, whenever you are naming, the double bond should get the first priority compared to your halogens. But when you are talking about the functional group, what happens? The functional group bearing carbon atom should get the higher priority compared to that of your double bond. So if you remember, try to write this 2 side by side, these 2 examples, so that it will be clear when you are reading in your exams. Is that clear? Okay. Let us now see the nomenclature for our phenols. Okay, so in which our hydroxy is attached to our benzene ring, directly to the benzene ring. So basically, if I'm going to write in this way, OH, of course here the common name and your IUPAC name both will be phenol itself. Okay, and in case if I'm going to give a substituent of a methyl group, that is your CH3. So which position it is, ortho, meta or para? So with respect to this position, main group, it is in the ortho position. So the common name will be what? Orthocresol. Orthocresol. So whenever we are having such CH3 and OH group, will be called as that common name will be cresol. But since it is in the ortho position, It is called as what? Yes, orthocresol. Similarly, if I am going to write it in this way, CH3 and over here as OH. Yes, so yeah. Now this is in what? With respect to this group, it is in ortho and a meta position. So how can I write metacresol? Metacresol. Yes. Similarly, now when I'm talking about this position, here CH3 and here is your OH, what I can write? Yes, paracresol. Are you able to understand? Paracresol. In case if you are having, okay, let us take now IUPAC name also. Sorry, IUPAC name for this one, what it would be? Yes, how will you number it? So this will be what? 2-methyl phenol. 2 first is second. 2 hyphen capital M methyl phenol. Whereas the second part will be what? Yes, 3-methyl phenol. But this will be 1, 2, 3. I am taking this one as my parent function group. So 3-methyl phenol. Whereas over here it will be what? 4-methyl phenol. So these are what? The IUPAC name. So in case now if you are having the system is in this way, here will be your OH and here will be your OH. So basically the common name it is called as what? Catechol. 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 But its IUPAC name, what you can say? Benzene C hyphen 1,2 diol. Why I have retained E over here? Why? Because it is not a vowel. Okay, benzene 1,2 diol. Similarly, in case if you are having like this OH, here if I am going to write OH. So here what you can say, it is called as a resorcinol. Certain common names are very much important. It is called as what? Resorcinol. Its IUPAC name will be what? Yes, benzene hyphen 1,3 diol. Similarly, if you are having this part OH and an OH in this way, so its common name we will be calling as a quinol. It will be called as what? Quinol or a hydroquinone. How will you name it? IUPAC name benzene 1,4 diol. Is that clear? So these are some of the IUPAC names of our phenols. So what is the main thing you have to remember in the nomenclature? Whenever we are writing for the names, IUPAC names of your alcohols, alkane into E is replaced by OR. Is that clear? So whenever it is having more than one hydroxy group, then you have to use the multiplicative prefixes. We have to K, di, tri, tetra, like that. They are called as what? Multiplicative prefix. Recall once again, I'm just recalling you, whenever you're writing the IUPAC name, what you have to remember? First comes your prefix. First comes our prefix, which indicates what? These substituents along with their positions. Then comes our root word, which means what? Which represents our number of the carbon atoms. Then comes our primary suffix. Primary suffix, which indicates what? Yes, which indicates the homologous series, whether it is ane, ene or ine. Then comes our secondary suffix. What does it indicate? The functional group. So this is the general protocol of writing the IUPAC name. So this will, when you are following this, so remember, prefixes can also have a position, that is your 2, 3 and the position. Even your primary suffix can also have the position. Your secondary suffix can also have the position. So along with the positions, you have to write their nomenclature. Is that clear? So we have seen certain things. Then we also saw that what is the main difference, how to give the priority in case if you are having a double bond. So whenever a double bond is with a functional group, so the first priority should be given to the carbon atom bearing that functional group. The quite ulta concept what we have studied in the haloalkanes and haloarenes. In haloalkanes and haloarenes, whatever the halogen groups were there, they were not the functional group. Instead, they were the substituents. So whenever a double bond is along with an NO2 alkynes or also your halogens, the priority is given to first double bond. So but when double bond is along with the functional group, priority will be given to the functional group. So you just write this example side by side. It will be very much useful. Then we saw certain nomenclature of our phenols. So in today's video we have seen majorly the classification of alcohols and the nomenclature of the alcohols. In our next video, we are going to see certain important structures of the alcohols and the ethers. Okay.